All right, I think we're ready to go. So this is right directly related to problem number three. We are looking at a measured voltage. Okay, so we have ourselves a measured voltage, and let's think of it like this: we're measuring the voltage through an unknown device. That device is going to be it's going to have some resistance R. We don't really know. But what we do know is the measured voltage, V sub M, and I could just say delta V sub M. And we also know the measured current, delta I sub M. So this is just the way I'm labeling it. Of course, this is not isolated. It's just not out there in the environment without some kind of voltage source, plus, minus. And so this voltage source is here, and it's going to be a delta V. All right. And so I'm saying delta V, and I'm trying to be specific with the delta V sub M as far as its measured voltage going through this resistor. But this particular voltage is the voltage of the battery. Now we're going to look at the voltage across the resistor. And so if I am going to be, kind of clear, we put our detector or our multimeter here, and we're going to get some measured voltage. And I can break the circuit right here. We'll call this A. All right. Well, nope. I'm going to call that. I wish that I could just erase part of the line. And I'm just going to put the resistor in line. I mean the ammeter in line. And so, just in case you can't see that, this should be. Uh, get rid of that. Let me make this a little bit bigger. This is my measured current. Okay, so we're actually going to have a delta measured current, and I guess I could still say the same thing. Is that confusing or what? I'm going to put delta I. No, that's not confusing. All right, because we're going to have 2 points. So we have 1 point, all right, and it's almost like it's on a chart. Okay, so if we have ourselves a chart here, if we have ourselves a chart here, we would, and we're looking for resistance, then the resistance, we know that that is voltage over current, right? And so we would have our voltage here, measured voltage, and then our measured current here. And we would have some point here, and we would have another point. So it's like this is our first point, and this would be our first point. And then we have our second point, and this would be our second point. Okay. And so, of course, we can do like so, and we know that R is just going to be the rise over the run. So this is our rise, and this is our run. And that's the kind of equation that we will use. So R is just going to be delta V M over delta I M. Now, what does that equal to? Well, we could see that we have 27.1 minus 14.1 divided by 6178 minus 3.101. Both of these are to the negative third power. Okay, so I'm hoping that I'm making myself clear. without belaboring the topic too long. But we have one measured, well, we have our second measured value minus our initial measured value, or our first measured value, and then we have our second measured value for the current over our first measured value for the current. And that's what I'm doing down here with these numbers. Okay, I'm taking them directly from these values up here. So R, we can now calculate R, okay? And I, again, will use my calculator here, and I'm just going to start over. So this one was problem one, okay? And then we're going to have problem two here. All right, so I'll make that a little bit bigger. So the first thing is going to be my first measured voltage. I think that should be explicit enough. And then I will have my second measured voltage. Okay, and that'll be right there. And then I'll have my uncertainty in these measures. So they're going to be the same. Uncertainty. And this is going to be in volts. Okay. And let's just go ahead and